Alright, so today I'm going to talk a little bit about my final project for my Introduction to Computer Programming class, which I call defuguer. Defuguer is a Python package that I am using to help me analyze Bach's Fugue in C# major, this piece here. So Python is a computer programming language that's used a lot in data science and in the biomedical realm. And music analysis is something that's done by musicians and by performers to gain a better understanding of a piece of music, to know what a composer intended, and to kind of get a sense of what makes a piece that piece. So I wanted to see how I could use the methods that I learned in Python to gain some insight into this piece, Bach's Fugue. So the first challenge that I had when I decided to do this project was how should I represent music in Python in this environment? And so at a basic level, in order to compute with notes, I'm using kind of the traditional 12-tone method, which gives each note name, A through G sharp, an integer. So C is 0, C sharp is 1, so on, until B is 11. And so once you have these integers, you can compute with them, you can manipulate them, and you can deal with them in the way that a computer would. So once I have this basic system, I created Python objects to do this. And now Python objects, they're classes of objects that have certain attributes. So the class note, for instance, has the attribute pitch, and the pitch is going to be the letter name. The length, which is the rhythm, 1 is a 16th note. You can change that so that it's 4 is a quarter note, 8 is a half note, etc. The value is going to be the integer associated with the pitch, 0 through 11. And then the octave is going to say what octave on the keyboard is it. And that way, instead of just having 0 through 11, you can have 0 through 87. So a C cannot just be a C, it can be middle C or an octave above middle C, so on. So here's how you create a note object. So I'm going to create middle C. So middle C has the pitch of C. I'm going to give it a length of 4, so it's a quarter note, and the octave is 4. That's where it is on the piano. So once I have this, the next thing that objects have in Python are methods. So we have this get pitch, get value, realize, and what these will do is do certain things with the data with the object. So when I realize this, we have, so get pitch will give me the string, it'll give me C. Get value will give me the number that's associated with it, 0. Realize will put it in the rhythm, so we have 4 of them, 4 16th notes, 1 quarter note. And then 39 is the actual note on the piano that is middle C. So once I have these note objects, the next thing I did is create a class of measure objects. So just like the notes, a measure object will have certain attributes. There's numeric, and this is going to be all the notes in the measure represented from 0 through 11. The tonality of the measure, 0 through 11. The measure number, where it is in the piece. And then absolute, which is depicting each note as 0 through 87. So I'm going to define this is the first measure of the piece, this measure here. And so I'm going to define this using this variable, test measure. So this is the way that it's basically represented, 0 through 11. It's in the key of C sharp, it's measure number 1 in the piece, and here it is 0 through 87. So here's some methods that I defined for this class. So we have just the get numeric, which just prints the basic form of the measure. Then we have retro, which is this, but backwards, so the retrograde. We have invert, which gives you the inversion. It's all flipped around 8, so 10 becomes 6, 8 stays as 8, 6 becomes 10, so on. And then transpose to C, which will take the measure and move it from whatever key it's in, this one is in C sharp, down to C major. So it moves everything down by 1, 8, 7, 10 to 9, so on. So once I have all these data, and all these different objects, I have this module of formatting, which are all these functions that'll help me deal with the information that I have about the measures and format it the right way to create new measures, to create notes, and then eventually to store the data. So here are some of the functions that I have. And these functions are really kind of the core of what this package does, because it allows me to take raw data and do all these really useful things with them. So once I create these objects, I store them in a TSV file here. So this is for the soprano voice of the fugue, the top voice, and it's all 56 measures, and these are the data that I have regarding them. And I have another one for tenor and another one for bass. So now that I have all these data, my goal with them is to do three things. So first visualization, then chromaticism, and then finally providing a user interface so that anyone, a musician, could just sit down and get some information delivered to them. So with visualization, I wanted to give a clear kind of graphic depiction representation of the piece. So I did this just by graphing the pitches of each voice. So here you have the entire piece. You have the blue sopranos represented here in blue, tenor in red, and then the bass in green. And these are all measures, and this is kind of a nightmare to look at, not very useful, so this function that I wrote, graph measures, lets you zoom in and just shows certain parts of the piece. So here are just the first 6 measures, which are the introduction. So I'm going to play an example of an MP3 of this, so you can kind of see why this is useful. So the point of this is that you can look at this graph, and without going through and doing any really complicated musical analysis by hand, you can just say, well, this is the shape here, the same shape that's here, and the same here, just kind of moving down in this kind of vertical way. So let me play that and you can hear what that's representing. Now the same thing is going to be in the tenor. And here in the bass. So this gives you a really kind of clear and obvious way to see what parts of the piece are similar, and here you can see that Bach is using this imitation technique in each of the voices, just moving down a little bit on the keyboard each time. And this was kind of an obvious example, so you can take this function, you can go through and just look at different parts of the piece. So for example, here are the next few measures, looking at just the soprano and the tenor, ignoring the bass. And you can see here, there's a lot of overlap here, so when you're playing it, it's really hard to keep track of which voice is which note belongs to which voice, because they're both in the right hand. And this can kind of help you differentiate between them, and you can find some other patterns here. For example, we have this kind of plateau shape here, the same shape that's here. Not as obvious as with the theme, but it's still there. Here is part of the development section, where we have the tenor voice drops out, and then you just have the soprano and the bass voices where they get really busy and kind of imitate each other here. And you can kind of see there's this kind of upside down thing going on here. And so this gives you a way in this to see how, you can easily see how different this is from up here, and so on. And finally, here are the last few measures of the piece, where they all level out on nice long half notes. So the next thing I wanted to do was to look at the chromaticism of the piece. Chromaticism is defined as notes that are outside of the primary key of the piece. So the primary key is C# major. There's 7 notes in that key, but you're not just going to have those kind of notes throughout the entire fugue. So this is going to calculate them and measure how chromatic different sections of the piece are. So I wrote this function diatonic tester, which is very simple. It just takes the notes of a measure, and it measures what percentage of those are also in the primary key, which is C#. So for that first measure that I defined up there, 100% of them are in C#. That makes sense because that's the first measure of the key. You kind of expect that. Now, so this will graph the entire piece according to its chromaticism. So you see here, it starts with 0% chromaticism, everything is diatonic, which again is what you'd expect. So these first 6 measures are what I played earlier, and these are the introduction. There are a few unusual notes there, but in general it stays very close, and this low point here is when the introduction ends, and when all the music has been introduced, all the voices have been introduced, and then it kind of shoots up into this next section, and this is called the development section. And just like you'd expect from the name of development, it takes the music and it does different things with it and it develops it. So you'd expect it to kind of have these higher levels of chromaticism, and you can see these peaks here, where it grows in chromaticism. Here are the really chromatic parts. Eventually comes back down, goes back up, and then it ends here in the main key. So you have this kind of overall arch, of how the piece progresses and develops. And then you have these kind of mini moments of climaxes, perhaps, or of chromaticism can be very intense. It can build tension. And so as a performer, you can go back and you can see, okay, so this measure 18, this is the most chromatic measure of all. Here are the other very chromatic measures. And then you can go back and you can, as a performer, say, okay, what's happening in this measure? Why is it so chromatic? What does that mean for how I'm going to play it and for how I think of the piece? This part of the project did not work out, so I'm not even going to talk about it. So the last thing that I have is a user interface that I call Musikgeist. And this is basically so that anyone, a musician, a performer, can sit down and have this information delivered to them. So it's this kind of basic interface with Bach talking to you and asking, what do you want to know about this piece? So let's say we want to see a graph, like what I'd shown earlier. So I'm going to hit 3. I'll say, let's look at measures just randomly, let's say 4 to 9. So there we have it. So blue is soprano, tenor, and then you have all of those voices. Do you want to see another section? Sure. I'll just look at 1 to 2. And then you can really focus on those. I'll go back to the main menu. Anything else we want to do? Let's ask Bach, how many kids did you have? So he had 20 sweet little kids. All right. So when you're finished here, you can quit out. And there's Bach saying goodbye to you. Yeah, so this piece kind of provided some ways that traditional hand pen and paper theory analysis would be kind of difficult to come up with, like that graph of the chromaticism or a graph of all the different notes in the piece. So I think that this kind of provided new ways to look at the music and to understand the music. So thank you.